So welcome to day 33 of this Python learning journey on Excel Ireland channel. So on day 31 and 32, we started a new course called Joining Data with Pandas, where we look at how to combine data's two tables or two or three tables or even four tables in probably Excel files, CSV files, or from any data source, how to combine or merge them together using the Pandas library in Python. So on day 31 and 32, we've covered a couple of lessons in this our Python course, which is joining data with pandas. If I show you a quick overview of what we did on day 31 and 32, this is the Python file that we use, the Jupyter notebook we've used for those 2 days. So if you want to understand what we've done here, basically what we've done was to use inner join to combine two or more tables together in Python, and we did some basic analysis so far on it. So on today's lesson, we just continue to the chapter 2 of this joining data with pandas. So we've covered all of that was covered in chapter 1. If I click on continue, we just go back, we just start chapter 2 where we'll be looking at left joining in Python. So welcome back to the channel and welcome to Excel Island, where the goal and the objective is to learn and master Python over the next 100 days. And today is day 63. So if you're looking to upskill yourself in Python or you wish to become a data analyst this 2025, I encourage you to study on this channel where I'm going to be live streaming this Python learning journey. And if you're just seeing this live stream for the first time, it all started from day one, where we actually look at the Python basic, which is introduction to variables, um, some Python basics. Obviously, I can't actually remember that right now because we've covered quite a lot over the past 33 days. Just go to the live stream tab on Excel Ireland YouTube channel. You see Python from day one there. Also, if you're looking to upskill yourself in SQL and Power BI, I have a couple of live streams there where we covered so many concepts in SQL and Power BI for a period of Power BI lasted for 79 days, 70 days, and SQL lasted for 100 days with a lot of files and projects you can practice with in those two in those two amazing tools. Probably with those two amazing tools rather. Sorry about that. So we just continue from where we stopped on this Python for data analysis, which is actually joining data with pandas in Python. Let me just go back to sharing my screen. So this was what we learned 23 hours ago, which was just yesterday. So the goal is to live stream daily for 1 hour learning Python. So the idea behind it is to be consistent with the learning and cover on the what you need to cover as fast as possible without uh, or getting burned out or anything of such. You need to understand that this is a highly technical skills. It takes a couple of months to actually master data analytics too. So the earlier you get to it, the better for you to learn fast and cover the concepts you need to cover. So this was just all what we've learned on day 31 and 32 based on this chapter 1, which is data merging basics, where we did inner join. So today we'll be moving to the chapter 2 of the course, which is merging tables with different join types. Probably we'll be looking at left join and other join like right join. So if you're familiar with joins in SQL, Power BI, and Excel, when you're building the data model, especially in Power BI and Excel, definitely in SQL too. So these are the similar join knowledge you need to know. We're just doing the same thing in Python also. So without any other delay, let's continue on the chapter 2 lesson. So we're spending just an hour on this live stream. So we spend just few minutes, less than 5 minutes on the introduction. And I'm just making sure the live stream is on.
Greetings and welcome back. In this lesson, we'll discuss how a left join works, which is another way to merge two tables. Before we start talking about left join, let's quickly review what we've learned so far. In Chapter 1, we introduced the Pandas merge method that allows us to combine two tables by specifying one or more key column to link the tables by. By default, the merge method performs an inner join, returning only the rows of data with matching values in the key columns of both tables. In this lesson, we will talk about the idea of a left join. A left join returns all rows of data from the left table and only those rows from the right table where key columns match. Here we have two tables named left and right. We want to use a left join to merge them on key column C. A left join returns all the rows from the left table and only those rows from the right table where column C matches in both. Notice the second row of the merged table. The columns from the left table are filled in, while the column from the right table is not, since there wasn't a match found for that row in the right table. Let's review another example. To help us learn more about left joins and other concepts in this chapter, we will use data from the Movies database, a community built movie database with info on thousands of movies, their cast, and popularity. In our next example, we have two tables from the Movies database that we want to merge. Our first table, named Movies, holds information about individual movies such as the title name and its popularity. Additionally, each movie is given an ID number. Our table starts with 4,803 rows of data. Our second table is named Taglines, which contains a movie ID number and a tagline for the movie. Notice that this table has almost 4,000 rows of data, so it contains fewer movies than the movies table. To merge these two tables with the left join, we use our merge method similar to what we've learned in Chapter 1. Here, we list the movies table first and merge it to the taglines table on the ID column in both tables. However, notice an additional argument named how. This argument defines how to merge the two tables. In this case, we use left for a left join. The default value for how is inner, so we didn't need to specify this in Chapter 1, since we were only working with inner joins. The result of the merge shows a table with all of the rows from the movies table and a value for tagline where the ID column matches in both tables. Whenever there isn't a matching ID in the taglines table, a null value is entered for the tagline. Remember that Pandas uses the NaN to denote missing data. After the merge, our resulting table has 4,805 rows. This is because we are returning all of the rows of data from the movies table, and the relationship between the movies table and taglines is a one-to-one. Therefore, in a one-to-one merge like this one, a left join will always return the same number of rows as the left table. Now, let's practice some.
I think left join is quite straightforward. So left join is more like one-to-one relationship. Okay, let's continue. Okay, you could take notes here. So I think we'll be using, I don't know the database we'll be using for this. Okay, they mentioned the movies and financials table will be used here. Let me quickly check if I have access to those two tables. So this was the chapter 1 code, the Jupyter 5 we used for chapter 1. Another challenge we were able to solve rather for chapter 1, which is just inner join. We only practice inner join mostly in this chapter 1. And we also use inner join to combine. Yes, we did three tables. We combined three tables in this chapter 1. So that's what we want to do in chapter 2. So we want to use the movies and financials. Let me see. I think I have the financials table here. Yes, and I have the movies. Let me see. Do I have movies table? Yes, movies too. Okay, this is movies here. So all these data sets will be made available under the link in the YouTube description. If you want to have access to these data sets, just go to YouTube. The description, there's a link. It's very glaring. You see it once in a glance. So we have access to the tables. So just to start, I'm going to create a new Jupyter notebook for this chapter 2, which is inner join. So we practice inner join here. So in this chapter 2, we are going to be practicing left join. So what I will just do is create a new notebook for that. Okay, so I'm going to rename it to chapter 2. chapter 2, or left join, left join, and other joins, and other joins. So it probably will do right join also. Let me tell that. If I refresh now, I say I have my chapter 2 Jupyter notebook here. I'll just copy this line of code because definitely we'll be working with the pico file. The file we'll be working with here is a pico file. The movies table, you can see .p is a pico file. So we'll be using pico to connect to the data set. I'll be using pandas to do our merging to manipulate the data set. So these are the two libraries we'll be using here. Also, I'll just copy this line of code, which I will use to load those to connect to this data set here in my local machine. So load movies data sets. So I'm going to load the movies data set. So let's continue here. So the movie database is supported by volunteers going out into the world, collecting data and entering it into the database. So this includes financial data such as movie budget and revenue. So if you wanted to know which movies are still missing data, you could use a left join to identify them. Practice using a left join by merging the movies table and the financials table. Okay, the movie that don't have record for the budget, probably the budget that was used for the movie or the revenue generated by that movie. So you could just, let me just zoom in a little bit here. Okay, it's already zoomed in. Okay, so the movies and financials tables have been loaded for you. So what column is likely the best column to merge the two tables on? Okay, let me just use my Jupyter notebook here to connect to the movies database and the financials database. If I look at the movies database here, movies.p, so it is spelled movies. I'll just change this line of code here. So this was the line of code we used in chapter 1. So I'm just copying some that are similar. They are both the same code we'll be using to connect to the data set. Just to save time of typing, movies. So I'll just call it movies data. Okay, movies data. So if I run this code, well, I can see the movies data. So we have the movie ID, the title of the movie, the popularity of the movie, and the release dates the movie was actually released. And this is over 4,000 rows of data, 4,800 rows of data. So I could just say, I could just do something else here. So I could just cut this and only run this line of code and call on the movies data dot add here to return just few rows of the data set. So it's going to return just the first 5 rows here. So the second data I want to connect to is the finance data. We have the finance shares data here. So according to the instruction here. So this is the environment provided by DataCamp to practice the lessons. But I always prefer to use my own local environment also just to make sure I'm quite familiar with working in a real world settings. So I'm just going to copy this line of code one more time here. Make use of it here. So this time around, I want to connect to the financials data. Financials data set. I connect to here financials. Yep. Just make sure the spelling is correct, or else we get an error. Okay, so I'm going to change the file part here. Rather than calling it movies. So let's run this line of code. Voila. So how many rows we have? Different. We also have over 3,000 rows of data and 3 columns, which is the movie ID. The movie ID. So this is the common column between the two data sets, and that is the common column we used in the merging process. We have the budget for the movie, have the revenue generated by the movie. Let's do that edge as usual. We return those few rows of data. So the question is now easy to be answered. So according to what column is likely the most common column to match the two tables up, which is the ID. Voila, so we got that. So we want to count missing rows with left join. The movie database is supported by volunteers. Okay, we've done that. We read this. So merge the movies table as the left table with the financial table using the left join and save the result as movie financials. So let's merge the two tables together. I'll just merge the tables together in my Jupyter notebook and copy the results. So we want to merge movies data, this our movies data here, to the financial data on want to merge it to the financials data, this data, then comma, we'll merge it on this ID column, the common column on both table, in both table rather, on the ID column. We want to specify how we want to join them. If you leave the how clause, by default it is inner join. I'm going to mention a left join here. We want to perform a left join. If I run this code, I shouldn't get any error. No error there. So I can call on the movies financials data. Let's see what we have. You can see we've merged the two columns together based on the ID column. So the title from here, title, popularity and release dates, title, popularity and release dates, then budget and revenue, then budget and revenue from here. So that's how simple merging can be. Let's do dot add here just to return few rows of data. You can see. So we have how many rows do we have there? Let me just check quick back. You see our 4,800 since it is a left join. So everything from the left will be returned, which is from our movies data, and any matching record from financial data, we just pick the budgets revenue column. So we're expecting same rows of data, same number of rows of data rather. Okay. So the next person we've done that. Okay, I'll just copy this code from here and make use of it in this line of code here. Just make sure I change this to movies and this to financials. So if I run the code, let's see. Let's submit the answer. Oh, so we nailed this. So now let's count the number of rows in movies financials with a null value in the budget column. Since we have a null value in the budget column, because we have a null value here, because this movie, the records for the budget and revenue, what probably it was missing or they were not able to get that information. That's why we're having a null value, a null record here. But let's see how to do that. So count the number of rows in movies financials with a null value in the budget column. So movie financials, so count the number of rows in the budget column that are missing. So number of missing financial movies financials budgets, that should be count. Let me specify if I say remember how to count the number of rows there. Okay, let's copy this. Want to see. So I want to count the number of rows. Count the number of rows in the budget column that are missing. Want to count only the missing rows. Okay. So I'm going to use number of missing financial equals movie financial, which is this one here. I want to count only the budget column. I'm going to be using the isNull method dot isNull. is null function, then open brackets, then we just sum the null record there. Let's see. Voila, we got that. So let's run this and see the result that we have. So we have over 1,000 rows of for movies. No, the total record here is over 4,000 rows of data. So, but out of that 4,000 rows of data, over 1,000 rows of data is missing record for the budgets and definitely the revenue. So let me copy this here, and hopefully we know that. You can also use is NA also. You can also use it is N. Let me use this NA here, as if you are going to get same results. You can say is NA also. Let me see. Let's run the code. You can see we have same results. So you can use is NA or is null. Interesting. So to count the number of missing values in a column, you just mention the column and use is null or is NA. This should give us same result also. And just name it movie financials too. And let me run this data frame. Because we have same results. You can use is null or is NA to calculate records missing values in a column. Let's submit this. So great job. You used a left join to find out which rows in the financial table were missing data. When when performing a left join, the merge method returns a row full of null values for columns in the right table if the key column does not have a matching value in both tables. So we see that there are at least 1,500 rows missing data. That sounds like a lot of work. So exactly, that's a huge bunch of data to be missing over 500 rows of data. So let's continue. So enriching a data set. So setting out left with the merge method is a useful technique for enriching or enhancing a data set with additional information from a different table. So in this exercise, you will start off with a sample of movie data from the movie series Toy Story. So your goal is to enrich this data by adding the marketing tagline for each movie. You will compare the results of a left join versus an inner join. So the Toy Story data frame contains the Toy Story movies. The Toy Story and tagline data frames have been loaded for you. So do I have access to the Toy Story data set? Let me check my data set list here. Toy Story. Uh-oh, we don't. So we're definitely going to be practicing that challenge on their platform there. I don't have access to the Toy Story data set, so we can't perform the analysis on my Jupyter notebook here. But we can just practice it here for practicing sake. So merge the Toy Story and tagline tables with a left join. Toy Story tag, Toy Story and tagline. So the tagline table here, then comma on which ID? On ID column. The joining method is going to be I'm going to merge that on the left join. So let's see if we run the code. So with Toy Story as left table, merge it to tagline on the ID column with an inner join and save as Toy Story tag. Hold up. Okay, that is the second challenge. So the first one here is the shape is print Toy Story tag, 3 rows of data and 5 columns there. Let's submit this. Let's do the second one. So merge Toy Story and tagline table with an inner join. So I want to do the same thing, but this time around with an inner join. So I could just go back here and copy this just to save time. So we are back here. I'll just paste it here. Call it story tag. This time I want to do an inner join. So not I'm not going to delete this step of how. Let's run the code. This time we have 5 columns and 2 rows of data. The other one was 3 rows of data. If I go back here and run this code, this is 3 rows of data and 5 columns. This, if I run this code, oh, okay, it is missing there. I'll just get rid of this one here. So this is 3 rows of data and 5 columns. This is 2 rows of data, 5 columns. You can see, so there's a missing record there. So that's fantastic work. So if your goal is to enhance or enrich a data set, then you do not want to lose any of your original data sets. So a left join is much more better. So a left join will do that by returning all of the rows of your left table, while using an inner join may result in lost data if it does not exist in both tables. So a left join is kind of more popular than, than an inner join. So if you want to have access to all the data sets in the left table, definitely want to use a left join in that instance. So let's continue and see. So just ignore this. I just be learning and practicing some stuff behind the scene for the past 100 days. So let's see another challenge. We've covered these 3 lessons. So let's move to how many rows with a left join. Then we can start with other joins and practice. Okay. So how many rows with a left join? Select the two statements about left joins. Try running the following code statements. Left table dot merge 1 to 1 on ID. Left dot shape. Left table 1 to many on ID. So note that the left table start out with 4 rows. Okay, try running the following code statement. Okay, let's see if I run it. Let's see what we are going to have. How do I run this here? Uh, Hold up. There's no way for me to run this here. Hmm. Let's see. No, that's left table. Okay, let me just guess. Left table. I want to merge the left table 1 to 1. 1 to many. Mm. The output of 1 to 1 merge with the left join will have more rows than the left table. Mm. The output of 1 to 1 merge with the left join will have fewer rows. So let me just plug my system there before we lose power. Okay, we are good to go. So the output of 1 to 1 merge with a left join will have fewer rows than the left table. There's no way for me to run this. There's a way to run it here. I've actually forgotten how to run it on this IPython shell. But if I try to run this on my Jupyter notebook, I'm going to get an error. Let's see. Definitely an error. The left table is not defined. So let's see. Let me just go back and give this a shot. Let me just see this. Okay. So we have one to one here, on ID, left, left. Note that the left table starts out with 4 rows. So if it is one to one, definitely it's going to return all the rows from the left table. If it is one to many, this should return. So the output of one to one merge with a left join, we have more rows. One to one with a left join, we have more rows than the left table. No, it's not possible. The output of one to one merge with a left join, we have fewer rows. The output of one to many merge with a left join, we have greater than or equal rows on the left table. So which one should be the so one to many merge with a left join, we have greater than or equal rows to the left table, greater than or equal to the left table. That's correct. So a left join will return all the rows from the left table. If those rows in the left table match multiple rows in the right table, then all those rows will be returned also. So that's crazy. I'm sorry to use that word. That's much because if there are multiple instances of one to many on the right table, so all those rows will be returned also. Therefore, the returned rows must be equal to, if not greater than, the left table. Knowing what to expect is useful in troubleshooting any suspicious merges. Because left join is going to return everything on the left table. And since the relationship is one to many, that means there are many instances of one instance on the left table, there are many instances on the right table. So you're going to return those multiple rows of data. So it says a left join will return all the rows from the left table. So if those rows on the left table match multiple rows in the right table, then all those will be returned also. Okay, interesting. So let's look at other joins, for instance, and see what we can learn from other join types here. So right join to find unique movies, popular genres with right join. So let's see. Let's learn this lesson. So how many minutes have we spent now on the live stream? I don't want to also spend more than an hour. Just 30 minutes. Okay.
All right, let's continue on. You now know how to use the merge method to perform an inner and left join. The merge method supports two other join types. Let's start with the right join. It will return all of the rows from the right table and includes only those rows from the left table that have matching values. It is the mirror opposite of the left join. These example tables show the result of a right join. Only rows from the left table where the column C matches are returned. Where there isn't a match, the columns from the left table will be missing in the result table, like rows 1 and 4. For this lesson, let's look at another table called Movies to Genres. Movies can have multiple genres, and this table lists different genres for each movie. For our right join example, let's take a sample of this data, subsetting to develop a table of movies from the TV movie genre. Our goal is to merge it with the movies table. We will set movies as our left table and merge it with the TV genre table. We want to use a right join to check that our movies table is not missing data. In addition to showing a right join, this example also allows us to look at another feature. Notice that the column with the movie ID number in the movies table is named ID, and in the TV genre table it is named movie ID. The merge method has a feature to take this into account. The code for this merge has some new elements. First of all, we set the how argument to right so the merge performs a right join. Additionally, we introduced two new arguments named left on and right on. They allow us to tell the merge which key columns from each table to merge the tables. We list movies as the left table, so we set the left on to ID and right on to movie ID. Our return table has movies that match our table of TV genres. There does not appear to be any null values in the columns from the movies table. We could explore this further. However, let's move on to our last type of join. Our last type of join is called an outer join. An outer join will return all of the rows from both tables, regardless if there is a match between the tables. Here's a simple example of an outer join. where the key columns used to join the tables has no match, null values are returned. That is why in the result, the columns from the left table are missing in rows 1 and 5, and in column D, row 3 is missing. For an example of this, we filter the movies to genres table, as before, into two very small tables. One table has data on family movies, and the other has comedy movies. In this merge, we list the family table as a left table and merge it on the movie ID column. The how argument is set to outer for our outer join. Both of our tables have the same column names. Therefore, we add suffixes to show what table the columns originated. In our result table, every row is returned for both tables, and we see some null values. In our original comedies table, ID number 12 does not exist. Therefore, a null is shown. Similarly, in our last row, movie ID 13 wasn't in the family dataset, so it has a null. Let's practice.
Okay, so let's see how to use a right join and an outer join. But left join and inner join are quite the most popular you always use. Let's see how to do right join. Quite popular joiners with right join using outer join to select actors. Okay, so let's do those three challenges and stop here for today. So I think I have access to these two data sets used there. Let me check, which is the movies to genre, and I think the last one was, I think TV. Yeah, TV something. Let me see. Probably the cast, maybe the actors or something. Let me read the instruction first. It says movies. Okay, the movies table, sci-fi movies and action movies. Oh, let me check one more time. I have the movies table here. Movies table. Is there anything like sci-fi movies here? I do not have access to that, but I think we have actors movies here. Okay, let's see. So most of the recent big budget science fiction movies can also be classified as action movies. You are given a table of science fiction movies called sci-fi movies and another table of action movies called action movies. Your goal is to find which movies are considered only science fiction movies. So once you have this table, you can merge the movies table in to see the movies names. Since this exercise is related to science fiction movies, use the right join as your superhero power to solve this problem. The movies, sci-fi movies, and action movies tables have been loaded for you. So I only have access to the movies table here and the action actor movies. I think actor movie, yeah. Action movies. This is actor movies. They said action. It says action movies rather. So I don't have access to the action movies here. So sadly, I'll only be solving the challenge on here. So made action movies and sci-fi movies table with a right join on movie ID. Save the result as action sci-fi. So once we make the action movies, to the sci-fi movies, comma, on which common column? On. Just want to quickly check something. So I want to make that on the movies ID. But this time I'm going to use a right join. I want to use the right join this time around. Let's run the code. Voila. Let's submit the code and see. Okay, we got that. So update the merge to add suffixes where ACT and sci-fi are suffixes for the left and right tables. Okay, the left is going to be action movies. So we are going to say suffix. So the suffix means that we want to differentiate those columns that are common to both tables. We're going to use this suffix here. So my suffix here is going to be ACT for the left table, which is the action movies table. And sci-fi, SCI for sci-fi table. So this is going to be for the action movies. This is going to be for the sci-fi movies. Let's run the code so you can see, then you can see. So movie genre is going to be ACT, action movies, because the common column here to both table is genre. So we have genre in both table, both the action movies and the sci-fi movies. So if you know that this is coming from the sci-fi movies and this is coming from the action movies. Let's submit and see. Great. So from action sci-fi, subset only the rows where general column is null. So we only want to see where the general column is null. So sci-fi only action sci-fi, where this column. So I want to pick on that column and return the result there. When the column is null. That is null, or probably is NA. You can use this NA also. Subset AB. So you don't need to count. We don't want to count. Let's run the code and see. Ooh, it says what is not defined. Okay, perhaps to put this in quotes. Sorry about that. Just want to select the column from that. So great. So we've solved that. So let's submit this. It's now okay. I'm supposed to use this now, not is any, but I can use this any also. Okay. Did you subset the correct rows? Action sci-fi. Yeah, I subset action sci-fi. Let me read it. So from the action sci-fi movies, subset only rows. Action sci-fi movies, subset only the rows where the general art column is null. Yes, now. I just subsetted the correct column. Okay, let's get help and see. Oh, my mistake was not wrapping it. I didn't complete the code here. I don't need to complete the code since I don't want to return the results yet. We're not actually returning the results yet, so you shouldn't filter for that rows. Okay, let's see. Action sci-fi. Hmm. Let me see the solution again. So from action sci-fi, select only the rows where general account column is show this though. Let's see. Even with that, it is not going to return the results because I have to add print to it. Let me just reload the page again. Oh, I have to perform the merge again. That's not fair. So merge the action movies. Let's do it one more time. With the sci-fi movies, comma on the movies ID. But we are going to be using a right join. How equals to right. So we're going to add a suffix to it. So I did that easily by just picking up a suffix record there. Let's see. Okay, the suffix we want to add is this ACT and SCI. So we know that. So we want to count uh the is now record from this actual column here. So that was where we got hanged up. Just a minute, please. Four. So let's try to solve this next challenge. So and see. So from action sci-fi move, subtract only the rows where the general account column is null. So that is quite straightforward. So sci-fi only. So we want to subset only for this column that is null. We only want to return rows that are null in that column. Same thing we did in this instance here. Mm. Do you want us to count it? We're not actually supposed to count. Is null. Open and close brackets. Okay. Let's run the code and submit. Oh, did it subset the correct rows of action sci-fi? Exactly. We did the correct rows of action sci-fi. Let's see what it asks for us there. Mm. Let me just copy this line of code because we're not supposed to return the results. Let's see. So why did it accept that? We're not supposed to return the result though. Let me go back here one step. If I run the code, it should return the results here. Even the result was not returned. So is null. So this is going to return the result, but I can't show. I wish I could show that on my own Jupyter notebook here, so you understand what I'm saying. But that's by the way. Let's continue. So merge movies and sci-fi only using the ID column in the left table and the movies ID column in the right table with an inner join. Okay, I want to perform similar mistake, similar scenario earlier, but we need to mention our two join scenarios. Okay. It now says merge movies and sci-fi tables with an inner join. Movies and sci-fi only. So the movies and the sci-fi only. Okay. Movies dot merge. So I want to merge that to the sci-fi table on using and words column in the right table with an inner join. So inner join is default. So I'm going to mention left table on which column? It says made movies with an inner join. So made movies and sci-fi only using the ID column in the left table and movies ID column. Okay, left is on ID column, but my right is going to be right on. For the right table, on the movie ID column. Movie ID column in the right table with an inner join. So by default, you don't even need to mention the how. Inner join is by default. Voila. So this is what we have here. Interesting. Let's submit and see. Great. So well done. Right join to the rescue. So you found over 250 action only movies by merging action movie to and sci-fi movies using a right join. With this, you were able to find the rows not found in the action movies table. Additionally, you use the left on and right on argument to merge the movies table. You are a superhero. Definitely I'm a superhero. So let's see the last challenge, which is of a popular genres using right join. Okay, let's continue. So which two tables are we working? Pop movies and movies to genre. Let me see if I have access to those movies there, those data sets here. Oh, I don't have access to pop movies. We have movies to genre here. Let me even load these movies to genre and let's see what we have there. Load movies to genre column. Let me see the spelling. Movies underscore GNRS. Let's see. GENRES. That's correct. That's correct. Oh, just a minute. I need to make a call real quick. So I've actually loaded the data sets. I was just doing that while I was on the call. Real quick. So we just have a few rows of data here for this movie to journal. So it's so sad that I don't have access to the other data sets being used here, like this pop movies that was used and that sci-fi movies that was used earlier. Let me check again if I'm mistaken. Pop movies. Nope, not here. Not here. So let's try to solve this challenge here. So popular genres with right join. So what are the genres of the most popular movies? So to answer this question, genres of the most popular movies. So if you know the most popular movies, you will know their genres. So that's quite easy. So to answer this question, let me see how many hours we spent on the live stream. Oh, just 50 something minutes. Okay, we are on track. So to answer this question, you need to merge data from the movies and movies to genre tables, okay, in a table called pop movies. So let's try to solve this challenge rather. So in a table called pop movies, the top 10 most popular movies in the movies table have been selected. Okay, this was just a little data frame that was filtered. So the top 10 most popular movies in the movies table has been selected. So ensure that you are analyzing all the popular movies. Merge it with movies to genre table using a right join. To complete your analysis, count the number of different genres. Also, the two tables can be merged by the movie ID. However, in pop movies, that column is called ID, and in movies genre, it is called movie ID. So we're going to use left on, right on keyword here. So the pop movies and movies to genres table have been loaded for you. So merge movies to genre and pop movies using the right join. Save the result as genre underscore movies. Group genre movies by genre and count number of ID values. Okay, let's solve this challenge. Merge movies to genre, which is going to be the left table. Dot merge two pop movies. Pop movies. Okay, using a right join. We need to use a right join here. A right join. Right. But say the result as general to movie. We need to mention the left on ID because the common column there are on different name. Left on equals to this is movie ID. This is called movie ID here. While the right on is called ID rather. Let's see if you are correct. So then we need to count number of genres. So it says group genres by the gist genre column. Move this data frame genres to movie by this column and count the ID values. So we're going to count the ID values. Let's run the code. Ta-da. Voila. See the results here. So the most popular movies by genre should be the adventure movies. Interesting. Let's submit and see if we're actually correct. Voila, we need it. So nice job. So the right join ensure that you were analyzing all of the pop movies, you see from the result that adventure and action movies are the most popular uh, genre of movies. That is interesting. So let's do this last challenge here. We're going to complete this remaining lessons on the 34 live stream. So using an outer join to select actors. So one cool aspect of using an outer join is one cool aspect of using an outer join is that because it returns all rows from both merge tables and null where they do not match, you can use it to find rows that do not have a match in the other table. To try for yourself, you have been given two tables with a list of actors from two popular movies, Iron Man 1 and Iron Man 2. So both of these actors played in both movies. Use an outer join to find actors who did not act in both movies. So the Iron Man 1 table is called Iron 1 actors and Iron Man 2 table is called Iron 2 actors. Both tables have been loaded for you and a few rows printed so you can see the structure. Okay, this is interesting. So let's look at Iron Man 1 and Iron Man 2 movies. Save Iron Man 1 and 2 to the merge Iron Man actors left with Iron 2 actors tables with an outer join on ID column and set suffixes 1 and 2. Okay, let's solve this. Iron 1 and 2, Iron 1 actors merge to Iron 2 actors, Iron 2 actors on mm, so with an outer join on which ID can do the on join with table with an outer join on the ID column rather, yeah, on the ID column, on the ID column, and set this should be out. The out should be an outer join. It's going to be outer. Then the suffixes to the left table. So our suffix is going to be okay, okay. I could just copy this here. So this is supposed to be here, just this. And my out is supposed to be here. Just trying to follow how the code was structured. So our suffix is going to be our suffix is going to be 1. I'll just copy this. 1 and 2. So we know which column is coming from which column, from which table rather. Okay. Now create an index that returns true if name 1 or name 2 are null. Okay, okay. That returns true. Let's see that. This is name 1 and this is definitely name 2. What I could do is just select this line of code and run it. That should return something. It wouldn't. I have to use a print here. But let's try to solve it. So create an index that returns true if name 1 or name 2 are null and false otherwise. Okay, let's see how to do that. This definitely should be name 2. Let's see that in action. So this should be name 2. An index. How do you create an index? So this is create an index. Let's see. So if create an index that returns true if NA, name1 or name2 are null and false otherwise. So if is null, that should be is NA, open and close brackets, is NA2, open and close brackets. That should give us the index we are looking for. So our M should be, so if name and name2 are mixing, it's going to return true or false. Print the first few rows of iron 1 and iron 2. Let's run the code now. Voila, you can see. Okay. So name 1, name 2 missing here, character 2 missing here. Let's submit and see. Nice job, we nailed it. So using an outer join, you were able to pick only those rows where the actor played in only one of the two movies. Interesting. What if you want to see the whole data frame? I don't want to print edge. Let me just clean this edge. Let me just delete it and see what we have here. Let me run this code. So you can see we have 180 rows of data and 5 columns. That I won't be able to see everything. But I could move to the right like this. Can see some NA character here. I'm going to get an error because I didn't use .add there. Let's see. Let's run it again. So you were able to using an anti join, you were able to pick only those roles where the actor played in only one of the two movies. Okay, interesting. This is the character 1, ID, name 1. That's interesting. Voila. Great. So we should stop here. We spend at least an hour trying to solve these challenges in this system. We're able to nail most of the challenges though. That's interesting. So we'll be looking at merging a table to itself. Yes, that is self-join. So you can merge a table to itself. So how does Panda undo self-joins? Merging on indexes, index merge for movie ratings. Okay, interesting. So we'll be looking at this on day 34. Rather. Yeah, that should be day 34. Yes. All right. So thanks for staying to the end of the live stream. So if you found value in this learning journey of Python with me, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you in the next video on the channel. Do have a wonderful rest of the day.